Hi everybody. Now in this video we are going to talk about how do we make control chart on Minitab. I hope the video on what control chart is, what are its uses, how to interpret has been useful. Now we are talking about how do we make control chart and how do we choose which control chart to make. So see, control chart for both continuous data and discrete data are different. There are certain control charts that we prefer in continuous data, and there are certain control charts that we prefer in discrete data. So whenever your data is continuous, you have many possible options, but generally we choose three control charts. The very first control chart is individual moving range control chart. We call that IMR chart. Second chart is X bar R, or we call that mean range, and the last one chart is mean standard deviation chart, or X bar S chart. All right. So if you see in all these three charts, there is one thing common. These charts will show you two things. First, these charts will show you whether your process is within control or not. Secondly, the charts will show you whether variation within your process is under control or not. That's the reason there are two control charts in each of these three categories. If you see individual moving range, this is combination of individual chart and moving range chart. If you look at X bar R, or mean range, so it is combination of both mean chart and range chart. And third one, if you see mean standard deviation chart, this is combination of mean chart and standard deviation chart. So when do we use individual moving range chart, when do we use mean range chart, and when do we use mean standard deviation chart? So see, whenever you want to make a control chart wherein you just have one subgroup, then you go with individual moving range chart. And as a matter of fact, we use individual moving range chart very frequently. And if you add up some categories, if you add up some levels in your data, when your subgroup size increases, then you can choose to go with either X bar R or X bar S. So you choose X bar R when you have 2 to 5 subgroups, and you can choose X bar S when you have 3 or more than 3 subgroups, generally more than 3 subgroups. Okay, so now if I compare both X bar R and X bar S, so X bar chart in both the cases will be same. Yes, the range chart and the standard deviation chart will be different. Okay, now let's try to understand how do we do this test. So let me tell you, individual moving range chart we'll do when we just have one subgroup. Let me show you on Minitab how we do that. So this is the data that I have in my Minitab. This data is of sales. Okay, so you see here, this is single subgroup, this is my process. If I want to find out whether my process is under control or not, because I just have one subgroup, what I'll do, I would go with individual moving range chart. But if I want to check performance of sales shift wise, and if I classify my data of sales according to shift, such as data of sales in evening shift, data of sales in morning shift, data of sales in night shift, then I can go with either X bar R or X bar S. In this case, because I have 3 subgroup, so you can do either X bar R or X bar S. But we should prefer, if it's possible to do X bar S, you should go ahead and you should do X bar S chart, because standard deviation is the stronger measure of variation than range. And now let's first do IMR chart. Okay, individual moving range chart. So let me show you what individual moving range chart does. Now, a typical individual moving range chart will look like, first let me show you how do we do this. The navigation path for individual moving range chart would be, go to stat, in stat go to control chart, in control chart go with variable charts for individual. This is variable chart, we are working on continuous data, and I have single subgroup. So individual moving range chart, just select that. Now choose your interest of data. My interest of data is sales, right? Now I would do okay. So this is how individual moving range chart will look like. And you can see here you'll get two charts. The first chart is individual value chart, second chart is moving range chart. Now what is individual value and what is moving range? Let me show you that. So this is the data that I had. Now I have pasted that data in Excel to make the interpretation simpler. Now see here, this was the data of sales. Now let's go, I'm sorry. So what our control chart did was, our control chart found out the average, I mean the mean of all the sales data. Okay, now we got, this is the average, right? And once we got the average, on the basis of average, my individual chart calculated control limits. To calculate control limit, you need mean and you need standard deviation. Okay, so based on this, my mini tab calculated control limits. Let me show you again. See here, my mean is 9285. See here, 9285 is my mean, right? And what it did was, it plotted these all data points. These all data points are nothing, I'm sorry, but this data point that you can see. See here, the first data point is 12,679. Let's put a cursor here. 12,679. Similarly, all the data points has been plotted. This is how individual chart will plot the data in individual value control chart. Okay. Now the next chart just below individual chart you can see is called moving range chart. Now what is moving range chart? Let me show you here. So in moving range chart, we'll find out the difference of consecutive value. How? Well, this minus this. This is how we got difference of consecutive data points. Now again, this minus this. Similarly, we'll calculate difference of consecutive values, and wherever you see this negative sign, please ignore that negative sign, because we here because we are concerned with the variation that is present in our process. So we don't take variation negative, right? Negative has no role to play in variation. So this is how I got difference. This is how I got moving range. So what is moving range? Moving range is variation or the difference between the consecutive data points. So in some way, moving range is giving me idea of the variation of the consecutive data points. Now, if you see here in Minitab, this chart, this moving range chart is essentially showing me whether the process of difference between individual data points is under control or not. So let me show you. Again, you will calculate mean of all these values here. This mean is anyway not correct, because this, while calculating average, what it has done is it must have subtracted these values which are in which have negative sign before it, right? So that is the way this moving range chart will calculate its mean, and on the basis of that it will calculate upper control limit and lower control limit, and this will plot all these values. Okay, last value is 1400. Let's go here and check here. 1400. Okay, so this is how this chart is plotted. So I'm sure now you have understood how this chart was made. Now let's understand how do we interpret these charts. So the very ground rule is, the very simple rule is, whenever you want to study a process, so first of all, as a rule, you will have to look at the variation control chart. See, we have two control chart. First is control chart of process. Second is control chart of your variation of your process, right? So first we'll see whether variation of my process is under control or not. If variation of my process is not under control, I would not look at the control chart of my process. So first, this control chart has to pass. If this control chart doesn't pass, I cannot go and look at this chart, because Variation is the very basic feature of any process. When variation is unpredictable, then you cannot rely on your process chart. And trust me, the reason we make this moving range chart is because at times your process chart, at times your individual chart cannot identify some special cause variations. So let me give you an example. Now let's say we are making control chart on your earning, on your salary. How much did you earn? I have data for last 12 months for your earning, and I made a control chart on your earning. So let's say you can see here lower control limit, upper control limit. Suppose I can see here the average your average earning was 50,000, your lower control limit was 10,000, and your upper control limit was 1,10,000. That means 110,000. Now what I found was there was a month wherein you got the salary of say 1,09,000, and very next month your salary there was a stiff fall in your salary, and you just received say 11,000. See the stiff fall, right, from 1,10,000 to 11,000, and still it has not exceeded this control limit. That means still we cannot call that a special cause variation. So this process chart cannot detect any such sharp rise or say a sharp fall that is present in our process. If I make moving range chart, this chart will easily identify such a special cause variation, and you can see here there will be one red dot saying this is a special cause variation. Okay, so this is why we make moving range chart, or even in X bar R or X bar S chart, you can see there you can see range chart and standard deviation chart. That is nothing but that gives us idea of the variation. All right, so I'm sure now you know the basics behind these control charts. Now let's go to stat again, let's go to control chart, let's go to individual moving range chart. And you can select your column of interest and then go to this IMR options. Okay, in IMR option you can go to test. Now you remember I showed you 8 tests in previous video. 8 tests for a special cause identification. So see here, these are the 8 tests. Now most of the times you'll just try to find out this logic. This is special cause variation, 1 point greater than k standard deviation from the center line. But if you see, if you found that your process is good enough, and say you didn't find any special cause variation, no data point is going above and below plus minus 3 standard deviation from the mean, now in that case you would like to opt stringent measure. Now you would like to check whether there is any special pattern within that control limits or not. So if you want to check any such special pattern within those within those control limits, then select this all. Okay, and you can select one by one if you want to check what is a factor that is present there. If you want to know whether oscillation is present or not, so just choose oscillation. Okay, no oscillation is present. If oscillation would have been present, you would have seen here a red dot. Let me again show you. Go to IMR option, test. Now I selected trend and I selected one more option. See here, no special cause variation, no special pattern. Now let's go to test and add 2 more condition. Okay, see here, oh my god, good news. Now let's go and select all the condition. Unfortunately the data that I have seems to be under statistical control. Bad luck. So I cannot show you any special cause variation in this data because there is no special cause variation. Okay, but ideally if there would have been any special cause variation, you would see, suppose this is special cause variation, so you would see this data point would be just above this red line, and the color of this data point would be red. And if you put your cursor here, so it would give you idea. Observation 55 and this is the value. So if you want to find out observation 55, go here and find out observation 55. Observation 55. Sorry. So this was the value. Now find out whose performance that data point is, right? Find out that team leader, find out that supervisor, if that's a special cause variation, find out the reason why that special cause variation came, and treat that special cause variation accordingly. Okay, so I'm sure this video on IMR chart was useful. In case if you have any question, concern, do write to me. Thank you.